Okay, folks, I'm going to shift gears here a little bit. I'm waiting for some parts to come in. So I'm going to start working on the carriage. Okay, this is a steel plate, 16 by 16, and it is heavy. This is a ground plate. As you can see, it's ground on both sides, so that it's exactly what it's supposed to be. It's within a couple of thousandths of an inch in thickness. And then if you take a machinist square and check it, it's perfectly square on all four sides. This little puppy was expensive, so I'll include the prices. If I start seeing people interested in the videos, I'll start getting some price information together. Right now I seem to be talking to myself. Okay, I'm just going to find the center of the plate using a scratch awl from corner to corner. And why I'm doing that is because I want to find the center of the plate for the router. The router arbor will go right through that plate. Very good. Okay. These are the guide blocks for the shafts. I'm using lineal motion shafts. Those are on back order, so I can't show them to you right now. These are the bearings. This is 1.25 inch bearing, and it has all these ball bearings on the inside. And what I have to do is attach 4 of these to the plate. Now this you have to be very precise. So I have to make 4 holes for each bearing. So what I'm going to do is, I'm not going to take a pencil and poke it through the hole, because you're not going to get a very accurate hole that way. So what I am going to do, take a couple of pieces of masking tape, just put them down where the holes are. This doesn't have to be too precise. Okay. I'm going to pull it over the edge. I have a straight piece of wood here, and I'm basically just going to push it up against the wood and do the same in the front. Now I'm more concerned about the side, because I want these to be as parallel as possible to the side of the plate. If it's off a couple of hundredths of an inch on the front, that's not going to be a problem. Okay, right now that is perfect. Okay, forgot one thing. Sorry to keep you waiting. Okay, I have a big C-clamp here. It may have moved. That is perfect right there. Tighten it down a little bit more. Beautiful. Okay, what I have here is a set of center finders. And this is the machinist way of finding the exact center of that hole. These come in different increments. You want to use the one that is the tightest in the hole. Not too loose, that's for sure. Now if you take a look at this, it has a little pin prick on one end. So what you do is you just drop that down the hole. That fits nice and snug, you see that? And then you take a hammer and just slightly make a mark on the steel. Can release. Now you can't see it on camera because it's a very fine hole, very fine mark, I should say. So now I'm going to take my heavier prick and make a heavier hole, a larger hole. I should have had my heavier hammer, but I don't have that right now. Okay, the screws I'm going to be using fit right in here very, very neatly. No play at all. Now, I'm not quite sure what screw you're supposed to use for this. If you use a number 10, then you're going to have a lot of play. So I'm using an odd size screw. This is a number 12 screw, machine screw, with a button head, Phillips button head. Okay. So what I'm going to do now is take it over to the geared head drill press and drill out those two holes. Okay, this is my geared head drill press. By geared head, I mean it has like a transmission in it that's full of gears instead of belts, instead of V-belts. So the performance is much better. The bits don't get caught up, they don't stop or stall out when you're drilling. And I have a pretty huge 3JT Morse bit, Morse chuck I should say, in there. So what I'm going to do is start drilling. I'm just going to bring the drill bit down on top of the hole. Okay, I can see that the bit is going down straight. So I'm going to add a little cutting oil. Okay, it breached. Okay, that bit is 15/64, so it's about a 32nd larger than the number 12 screw. So I have a little play. You're going to have a little play. Okay, at this point you can take the masking tape off. Okay, I'm going to bolt a bearing block onto the plate. Okay, I'm going to clean this plate off with a little lacquer thinner. Just want to clean the glue off, the oil off. Because I'm going to reapply my masking tape for the last set of holes. Okay, I'm going to drop my number 12 by 1-inch machine screw through there. Same on that side. The nut. Going to make it fairly tight. Okay, this came out pretty perfect, I would say. Nice and flush. And these bearings, by the way, have a load of 1,200 pounds under use. That's quite a lot of weight. This is going to be a serious machine, that's for damn sure. Okay, so what I'm going to do now is repeat the process. Forgot something. Okay, I'm going to repeat the process using the transfer mark. Okay, this time I have my heavier hammer, and what I'm going to do is just remark them. you can actually feel the pin prick go right into the hole. You can take the tape off at this point because I can see clearly the mark on the metal. That's all the use of the masking tape does. It just makes it easier to see the initial prick. Okay, I'm going to go back to the drill press, knock those two holes out, and then clamp the bearing back down. So that is 1 down, 3 to go. That did take me some time because I had to set up the camera, go back and forth, this and that. But it's sitting in the holes, perfectly flush with the edge. Now I'm going to finish the 3 other. This should take me about 45 minutes to an hour. And then I'll show you the finished product.